Next, we go to the practical, that is the fineness modulus of aggregate. So same, we done the fineness modulus about the fine aggregate. Same procedure, but there is a change in the sieve size. So we require the sieve size of 80 mm size, 40 mm size, then 20 mm size, 10 mm size, and then 4.75 mm size. So these are the sieve size required. Remember, the aggregate of size is sample is very large, so we require only the size up to 4.75 mm, because the coarse aggregate are the aggregate which are having the size greater than 4.75 mm. So for this we use the sieve that is up to 4.75 mm for the sieving method, but for calculation we take all the sieve from 4.75 to 75 micron. So we see this in the calculation. First we go to the procedure, that is sieves are arranged in such a way that the largest sieve at the top in descending order. First is 40 mm, then 80 mm, 40 mm, 20 mm, 10 mm and 4.75 mm. So we have to take first the aggregate. First we make a weighing machine at a 0, set at a 0. Then put the aggregate So weight of the aggregate is 1000 gram. Then put this aggregate into the sieve, top of the sieve. As the top sieve is having the size 80 mm, so there is no sieve or no retain of the aggregate. So for 80 mm sieve sample, the weight of aggregate retainer is 0. Then next 40 mm sieve sample, it is also having the greater size, so all the aggregate are passing through this, so weight retainer is again 0 for 40 mm. Then next is 20 mm. This is the aggregate in 20 mm sieve. So the aggregate written on 20 mm. So it is all aggregate are written on 20 mm. No aggregate is passing through this 20 mm. So we have to take the weight written on a 20 mm sieve. Make it 0. So weight of aggregate written on 20 mm is 990.
खाली पडले बघायला 1000 होतो. खाली एक दगड पडले बघ.
So it is 1.
नाही आणि पडले खाली.
996 grams.
That is 1000.
So it is about all the aggregate written on a 20 mm sample. It is 996, so it is about the 1000 gram. Take it as 1000 gram, because the machine will be having some weight changes, so it will take as directly 1000 gram written on a 20 mm sieve. Then next is no written, so we make only calculation. One last is here. In 4.75 mm, there is one aggregate. Sorry, make it 0. 4 gram.
Okay.
So it is 4 gram. So 996 and 4 gram, that is 1000 gram. Okay. Then we see the calculation in a next video. Thank you. After performing the practical on a fineness modulus of aggregate, that is coarse aggregate, we go through the calculations. So Same table is prepared as for usual for the fineness modulus of fine aggregate. Serial number, IS sieve size, weight of aggregate retainer on in a sieve, that is in a gram, in percentage retainer, cumulative percentage retainer, and cumulative passing. So sieve size is 80 mm, 40 mm, 20 mm, 10 mm, 4.75 micron. So we use the sieve size only up to 4.75 mm for the practical, because the aggregate which having the size less than 4.75 mm are termed as the coarse aggregate. But for calculation we have to use the all the sieve size, that is up to 150 micron, that is 2.36, 1.18, 600, 300 and 150 micron. This is for calculation of the fineness modulus of the aggregate. Then next we go through the weight retainer, that is for 80 mm 0, as we see in practical. For 40 mm 0 gram, for 20 mm 996 gram, that is 996 gram, and for then 20 mm 996 gram, 10 mm it is 0, and for 4.75 mm it is 4 gram. So during the practical, for 4.75 mm it is the 4 gram. So taken this all the weight and a sum, that is 1000 gram, that is 1 kg weight of the sample taken. Then percentage retained, it is calculated by weight retained divided by total weight, that is 1000 into 100, that is 0. For 0 it is percentage 0, then next also 0, then for 996 divided by 1000, that is weight retained divided by total weight into 100, that is 996 divided by 1000 into 100, 99.6. Next also 0. Third, that is 4 divided by total weight 1000 into 100, that is 0.4. So it is the weight retained. Then for next there is no weight retained. So we'll make it is 0, 0 and 0 till 150. So it is the weight retained and percentage retained. And cumulative percentage, as we seen in fineness modulus of fine aggregate, write down first value as it is, that is for 0, first row it is 0, then add 0 plus next value, that is percentage retained. So 0 plus 0, that is equal to 0. Then next 0 plus 99.6, that is 99.6. Then 99.6 plus 0, that is 99.6. Then 99.6 plus 0.4, that is 100. Then 100 plus 0, that is 100. Plus 0, 100. Plus 0, 100. Plus 0, 100. And plus 0, that is 100. Then write down first value as it is, then add the next value into that value. Then we get the percentage, cumulative percentage retained. Then 100 minus cumulative percentage retained will give cumulative percentage passing. It is 100 minus 0, that is equal to 100. 100 minus 0, that is equal to 100. 100 minus 99.6, that is equal to 0.4. 100 minus 99.6, that is equal to 0.4. 100 minus 100, that is equal to 0 till the end. Then we have to take the summation of cumulative percentage retained up to 150 micron. So by taking the sum of this value, or by addition of this value, we can get the sum, that is 799.2, that is 799.2. Then to calculate the fineness modulus of aggregate, formula is fineness modulus of aggregate is equal to sum of percentage, that is cumulative percentage weight retained up to 150 micron. So cumulative percentage retained up to 150 micron is equal to 799.2 divided by 100. that is 799.2. So it is 2 divided by 100, that is 7.99. It is the fineness modulus of the coarse aggregate. So hope you understand all the procedure and the calculation of a fineness modulus for a coarse aggregate. If we perform the practical, then we can clear all the idea. So because if once you perform the practical, then we can understand why it is the cumulative retained or why it is cumulative passing is required, or how the particle size distribution is difference for the all sieve size. So we are trying our best to explain it through this presentation. So hope you understand all this procedure and the calculation. So thank you very much joining with us.